Next, let's talk about k-means, which is much more scalable than hierarchical clustering. Remember that each step of hierarchical clustering actually takes n squared time. And the good news is k-means only takes kn time, where k is the number of clusters and it's typically quite small. And the idea of k-means is actually quite simple. We'll first assume that we are in a Euclidean space and we have Euclidean distance. And we will start by picking k, which is the number of clusters. And then we will just initialize the clusters by picking 1 point per cluster. For example, you can just randomly pick k points and treat these k points as the initial centroid. Or you can just first pick 1 point at random, and then you can pick one of the other points one by one, and each of them will be as far away as possible from the previous point. So we want to make these k points as spread out as possible. And at the first step, we will first, for each of the n points, we will assign them to the closest cluster, basically the cluster whose current centroid is the nearest. And after all points are assigned, we will update the locations of the centroid of the k clusters, and then we will have new centroids. And since we have new centroids, in the first step, we will need to reassign all the points to their closest centroid. And sometimes we may need to move the points between clusters. And obviously, we will need to repeat step 2 and step 3 until converge. And what does it mean by convergence? Convergence means that the points don't move between clusters and the centroids stabilize. For example, let's say that we want to cluster all these points. And initially, we will just pick 2 points. And we pretend that these 2 points are their initial centroid. And then we will just assign all the points to their closest centroid here and here. For example, this point, it's closest to the blue centroid, therefore it's grouped into the blue cluster. And then in the second round, we will update the centroid of each cluster. For example, for the red cluster, we will calculate the average of these 3 points to get the new centroid, and similarly for the blue cluster. And we will start to reassign the points. And since this point is now closest to the red cluster as opposed to the blue cluster, we will move this point from the blue cluster to the red cluster. And this is the end of the second round. And similarly, we can let this process goes on. And this will be the end of the process. One important question of k-means is how to select k. One idea is that we can try a different k, and we can look at the change in the average distance to the centroid as k increases. As, for example, as you can see here, as the k increases, the average distance is actually decreasing. And the average will fall rapidly until the right k, and then it changes very little. So basically, this would be the right value of k. For example, if we start by choosing a k that's too small, you can see that there are many long distances to the centroid here. So this is not a correct k. And if we pick just the right k, we can see that the distances from the points to their corresponding centroids are all rather short. So this is a good k here. And for example, if we keep increasing the k to a point that it's too large, then you can see little improvement in the average distances, as you can see here. And this is not a good k either.